Okay, good afternoon. Welcome to the fourth session of the Sunoikisis Digital Classics module for fall 2016, which is the Digital History and Archaeology part of the course. This week, the module is again run by Valeria Vitale from King's College London, and I will be giving a little bit of background in a couple of places, just to break up the monotony. Not that Valeria is monotonous, on the contrary. I'll be introducing some monotony to an otherwise interesting presentation. So the topic this week is 3D modeling and computer-aided design. I just want to say very briefly a word about the title. We give it the subtitle computer-aided design to distinguish 3D modeling as we define it from what Sebastian talked about 2 weeks ago, which was what I would normally call 3D imaging, but he described as 3D modeling. So just to separate the two out. Another way of clarifying that would be that what Valeria is mostly talking about this week is 3D visualization, which is the visualization or the modeling of non-existent artifacts from direct or indirect evidence for those artifacts or buildings or so forth, whereas 3D imaging is taking an object that exists currently in its entirety, or if it's not in its entirety, we're only reconstructing that part of it which exists using direct image capture, as you saw 2 weeks ago. So for this session, Valeria is going to talk about a range of things which I think she will introduce in a moment. She's going to start talking about the applications of 3D modeling. I will very briefly talk about a couple of example projects and some of the advantages and shortcomings of those projects and the ways in which they illustrate some of the things that Valeria has been talking about. Valeria is then going to talk about a very important issue, which is the issue of documentation of 3D features, and then we'll move on to the discussion of the software and the exercise. I will give a very brief introduction of a couple of the software options that are available for 3D modeling, and again, some of the advantages and disadvantages of each, and the reason that we're choosing for the exercise the one that we are, which is not necessarily the one we'd be choosing if we were starting a project. And then Valeria will introduce you to the software, the Sketchup Make, and we'll show you some of the exercise that we want you to do in follow-up from this. So I think without any further ado, I'll hand over to Valeria to start us off.
Okay, great, thank you, Gabby. I'll share my screen. Just a moment. And you should see me now. Yep. Okay, so what are we going to present today? As Gabby said, is 3D modeling in the sense of building object, making 3D object from scratch. So what I would define as 3D modeling is basically creating digital three-dimensional representations of concrete or abstract, existing or non-existing objects, but from scratch. And of course, the distinction that Gabby was mentioning between 3D modeling and 3D imaging is by no means very clear and defined. It's more of a convenience kind of distinctions, and actually there are a lot of techniques that blur these lines, and I think this is actually quite interesting how the different 3D technologies do interact together in sometimes unexpected ways. And even within 3D modeling, there are actually various kind of technologies, various kind of approaches. And the one that we are going to look at in a greater detail is computer-aided design, or CAD, which is basically what architects do when they make models of your future house and show them to you. But there are other kind of 3D modelings, like, for example, procedural modeling, that is about procedurally generating entire cities, but according to parameters that have been input by researchers. So for example, you could say, okay, in this hypothetical reconstruction of an ancient city, I want 10% of the buildings to be 2 stories high, and 15% of the buildings to have a terrace, and 20% of the buildings to have a door on the main street, and so on. And then the software would randomly mix all these parameters and produce an hypothetical procedurally generated city. But there are also virtual world platforms. They used to be very popular some years ago, like Second Life or OpenSim, where users can build things in these virtual spaces and then interact with that. And they can have visitors looking at what they have built and so on. Or real-time engines that were actually developed mainly for the video game industry, but are more and more commonly used in cultural heritage studies as well. And they are quite interesting because they give you the idea, I mean, they simulate a walkthrough a 3D model, so they can try to give an idea of the experience of walking into or through and reconstructed ancient place. And we have digital sculpting, free modeling, and really this family, it's constantly growing. There are always new technologies, new approaches, and it's a very, very exciting field, constantly evolving. But now that you have a little bit of an idea of how wide range of available 3D technologies there are, the other question that we may ask is, okay, what can we do with that? How can we use 3D models for cultural heritage? Well, the most popular, understandably, application of 3D modeling is trying to visualize things from the past that do not exist anymore in their materiality, or maybe never did, or maybe they have changed through times, they have been heavily damaged or restored and so on. And we want to visualize another moment in their lifetime. And the applications as well of 3D modeling are constantly evolving as well, because as the technology changes, so do the applications. But just to give you an idea of some of the most common applications of it, well, I work mostly with buildings, so my examples will be slightly biased towards ancient buildings. In particular, you will notice a lot about Pompeii. But in a 3D model, in a virtual space, you can, for example, test things like lighting and shadows, and what was the effect, for example, of a certain illumination on the paintings and so on. Or you can test machines and features, like, for example, the functioning of theatrical machines or of a water feature, like an impluvium in a Roman house. You can investigate line of sight and what was visible from one point of the building, what was reachable from one point of the building. But I mean, you can go wilder if you like and even investigate planets alignment. It has been done. Or you can go more into the technicality of the materiality of the building. For example, make simulations about structural strength according to different materials and so on. But another very common application of 3D modeling, it's that actually these models, even very simple ones, they make architectural drawing much more understandable for the non-expert audience. So maybe if you're a trained archaeologist or art historian, when you see a 2D drawing, a schematic drawing of a building, you immediately can visualize that in your trained imagination. But it's not the same for everyone. So actually 3D models do enhance the readability of 2D conventional representations of architecture. Well, I am obviously a 3D enthusiast, but I think there are some pretty obvious pros in the use of 3D technologies in the study, investigation and representation and communication of cultural heritage. But we will talk about the cons as well, I promise. I'll try to be objective. Well, for a start, trying to make a 3D virtual restoration or reconstruction of a building is way, way, way cheaper and more manageable than trying to do a material one that sometimes is not even possible, not just because of funding. And even more important, it is completely virtual, so it is non-invasive and non-permanent. So we will never have the issue that we can see in actually a lot of archaeological sites when we see that the restoration that has been done in the past is now so embedded in the original material artifact that the two layers, the original remains and the restoration, cannot be separated anymore, to the point that the idea of the ancient place that was in the mind of the people that curated the restoration has now become the fake idea of the authentic look of the ancient place. And obviously we don't want that to happen. And with virtual representation, we are, let's say, more free to be biased because our representation is not making any actual change, is not going to have a permanent effect on the original monument. And also, as all digital projects, it is potentially infinite. Virtual space is infinite. So we cannot, we don't have to limit ourselves to one hypothesis. We can develop variants. We can have different, we can try different things. We can try different theories, as many as we want. We can collaborate with other scholars, and we can develop, parallel projects and compare them. Also, as every digital project, it is potentially open-ended, so we don't have to publish it in a book, we don't have to submit it, we don't have to put a full stop on it. We can always improve and always enrich it. Another quite exciting, I believe, aspect of 3D technologies is, as we were saying, when we can combine them and put together the benefits of different approaches. For example, putting together 3D modeling and 3D imaging, as we were saying before. So, for example, we could do, as you can see in this example, it is from a 3D visualization of one of the Trajan villas, that we could have a laser scanning of the original remains, and on top of that, build in a CAD software a virtual restoration of the potential look of the ancient building. Or we could use motion capture to simulate movement and performance in an ancient space, as one of the projects that Gabi is going to talk about later. Or we could use, we could combine multispectral imaging with 3D models, for example, using the multispectral imaging as a texture to map a 3D object, as we have done with some colleagues with this, with an artifact in Tallinn. Or you could use 3D modeling and augmented reality, as I've recently seen the Natural History Museum in Berlin has done. So you can see 3D models of the dinosaurs actually moving around you, and I bet that is incredibly engaging for the public. But an important point that I want to make is that 3D technologies are really, really engaging, both for the people that produce them and the audience that consume them. But the fact that they are that they look good, that they are interesting, that might even have a sort of cutting-edge aura, is not enough of a reason to use them. We shouldn't use 3D technologies just because we can, just because we got funding, just because they look good. We should use 3D technology, in my opinion, when they actually enrich our approach to the ancient world, when they allow us to ask questions and find answers that would have been otherwise impossible to get when they enhance and change the understanding that we have of ancient objects. And I want to particularly point out the way that 3D technologies, and in particular 3D modeling that deals a lot with space, landscape and architectural space, how the concept of space can enhance our understanding of ancient things, ancient places. So I will just mention a couple of some of the most, let's say, crucial element that define space, that some of the spatial kind of information that we can put into our representations of the past. And now this information can change and enhance our understanding of the past. So for example, let's talk about scale. That is definitely a spatial concept, and I'm sure there are a lot of classicists among you, and possibly some epigraphers as well. So for example, think of an inscription, one electoral inscription that says, vote for this person because this person is great, very classic electoral inscription. What you would expect is to find such an inscription written, quite big, as you can see, for example, in Pompeii, quite usually on the main roads. Yeah, very big and in a very invisible space. But what if the same exact words, so the same exact inscription, vote for this person because he's great, you actually find written very, very small and in the courtyard of a private house. They are exactly the same words, so we haven't changed a single letter, but you can easily understand that we are now looking at a completely different artifact. So that maybe wasn't an electoral inscription, maybe it was, I don't know, I'm not an epigrapher, I'm making wild hypotheses. It could be a commemoration, it could be a joke, it could be, I don't know, someone practicing their public writing skills, I don't know. But definitely I would say that we are looking at a different thing. And the scale and the location of these two hypothetical artifacts, I mean, the second one is not hypothetical, there is actually such an inscription in Pompeii, but scale and location have made these two things two different things, even if they have the same words. And another spatial concept that I want quickly to mention is again scale, but in this case connected to visibility. So this is an hypothetical reconstruction of the Theatre of Pompey in Rome that was developed by the King's Visualization Lab. That now sadly doesn't exist anymore, and it is, quite a classic 3D visualization of an ancient place. And I wasn't particularly struck by it until I realized that I'm sorry, I don't really have a pointer now, but I don't know if you can see that there is a tiny black dot on the stage. And that tiny black dot that you can see enhanced in this other picture is actually a human character in scale that was added there through motion capture, as again you will see later when we talk about this project. So you see how small is a human actor in that environment. And I didn't have an idea of how big, how almost overwhelmingly big was the Theatre of Pompey, until I saw it in scale compared to a human figure. And again, my understanding, my approach to this monument changed after that, because now I wonder, okay, if the actors were so small in the view of a spectator, what kind of performances can you actually follow in that way? And what can you actually hear in such a big space? So maybe the performances were more like choreographies. Maybe there were, I don't know, battles, machines, horses. Again, I don't know. It's not my place to speculate about that. But surely my perception of this ancient place, ancient monument, has massively changed in the moment I put it in scale. And I think the 3D modeling is an extremely powerful tool to understand how spatial information can really, really, really enhance our understanding of the past things and past monuments. And another things that I believe 3D modeling excels at, especially when combined with other 3D technologies, is contextualization. Because yes, we go to a museum and we see a beautiful artifact, like for example this statue that comes from Herculaneum. It was on display alone in the, I mean, not alone as on the artifact, but it was exhibited in the British Museum in the context of an exhibition about Pompeii and Herculaneum. And of course, it's a very interesting artifact, and it already gives us a lot of information about Roman art, about Herculaneum, and we can already look at the eyes and the posture and the draping of the clothes and everything. But when we learned that this artifact was actually part of a group, it wasn't alone, it was part of a group of dancers, then we look at that artifact in a different way. And we start wondering maybe, okay, there were 6 of them. In what way were arranged? Were they one after the other? Were they one in front of the other? What is the relationship between their position? Were they paired? Was it random? Were they kind of, staging a choreography? And when we know that those statues were actually in an architectural environment, okay, this is not the Villa of the Papyri, this is the reconstruction of sort of the Villa of the Papyri at the Getty Villa. So please pretend this is the Villa of the Papyri. I couldn't find any other CC licensed image. So you can see at the center that there are those statues, and they are actually on a water feature. So there was some reflection and maybe some movement involved in the final effect, and there was certainly some interaction with the natural features, with the architectural features, and our whole understanding of that statue, you can see, is now completely different, because it's not anymore an isolated object. That is in space, that is in relationship with other objects, is in relationship with the space, with the light. And especially if we think of Roman architecture, and I apologize again because that is what I mostly deal with, they were absolutely keen on this kind of interaction, for example, between painted architecture and real architecture, or painted gardens and real gardens. And everything was supposed to be perceived together, to interact, to kind of blend into each other. And with 3D modeling, with 3D visualization, of course, we could never try to make things look like they were, but we can start trying hypotheses. We can start, we can wonder, okay, what if this thing was placed between the columns? What if this thing was placed in the garden? And asking these kind of questions. And same thing for the natural landscape. That is something else that can be investigated with 3D technologies, especially when combined with geographical technologies, which is a very, very interesting and rich field. And you can learn a lot about studying a temple like the Temple of Jupiter Anxur, but only when you consider that temple in its real natural location, and you see that it is on this incredible promontory, and you see that the view from there is absolutely unique. Then you understand much more about the religion, about how temples were thought about, they were planned, And again, we can translate this argument into non-natural landscapes like cityscapes and investigate what was the relationship between buildings, between the visibility of different buildings. And I'm sure that sometimes it was just random, because I believe that cities have always been messy, but sometimes they weren't. I'm sure that there was also some planning there. What were, for example, the first monuments that a visitor would see entering a city? I'm sure that that wasn't random, and we could investigate this kind of questions through virtual models. And now I give word to Gabby, because I think that it's up to him now. So I'll mute myself.
Okay, thank you, Valeria. I'm just going to share the screen for the slides. Great. Yeah, so this is literally only going to take 5 minutes, if that. I'm going to talk about a couple of projects that use 3D modeling and 3D visualization techniques, and the kinds of features they use and the kinds of comments one can make about these. And so I'm going to talk about Rome Reborn, I'm going to talk about the body and the mask, and I'm going to talk about the reconstruction of Çatalhöyük very quickly. Rome Reborn is a huge project attempting to 3D model effectively the whole of ancient Rome. This was first published in its first version in 2008 as part of Google Earth, which later disappeared, and so it's no longer available through Google Earth. But it was a massive. It was the largest project we'd ever seen of this kind relating to the ancient world. The current version, which I believe is version 2.2, is probably still the largest 3D visualization of an ancient settlement that we have, and it has all these massive buildings to a very high degree of detail. All the, as you can see in this image, all the main buildings we recognize in Rome, and also modeling lots of more mundane buildings in between. There were a few criticisms of this project, such as that when you get very close to a building, when you fly through the 3D model and look at buildings from street level, everything was too clean. Everything was perfect. There was nothing broken, there was nothing dirty, there was no garbage on the street, there were no people wandering around, there was no discoloration, no smoke, or anything like that. So it was a really idealized vision of Rome, as it would never have actually looked to anyone. So there was that as criticism, and the other criticism is that although a huge amount of very rigorous research no doubt went into the design of these buildings and the modeling and so forth, the documentation for that research, the documentation for which parts of these buildings are we reconstructing because we know they exist, which parts have been reconstructed based on evidence, and which parts of it completely imaginary, for example, was completely absent. A viewer could just go in, see that it all looked very nice, and if they were an architectural expert in ancient Rome themselves, they could tell which bits had good evidence behind them, but otherwise they had no way of telling. The other criticism of this is that the delivery of this project is almost entirely through images of those 3D models and videos showing walkthroughs and fly-throughs of parts of the model. And there were maybe more detailed demonstrations at project launches and similar public events where you could go and you could see these models through a 3D interface and maybe even play with them yourself. But there's no, otherwise the public don't have any access to the 3D models themselves. All we have is we know they exist, we can see pictures made of them, and we can occasionally see what they are. So it's an absolutely fabulous project, but it's not, we can't get close enough to it, and the documentation isn't isn't there to show us what it's built from. It is, of course, an ongoing project. It's been ongoing for a long, long time and will continue to be ongoing. So all of these criticisms may well be being addressed as we speak. But these are things to think about when you look at a 3D model of something of the scale of a city. These are the sorts of questions you want to ask about it. The second project I want to very briefly mention is the Body and the Mask in Ancient Theatre Space. This was a project completed in 2009 by the King's Visualization Lab, formerly part of the King's College London Department of Digital Humanities. This was a project that was built on some earlier projects that had built massive reconstructions of ancient theatres, and what you saw one of them that Valeria showed you, the Theatre of Pompey earlier, and they used the 3D technologies to add to these massive models an element of the performance. So they built masks of the kind, reconstructions of the kind of mask we believe were used in ancient theatre. They scanned these masks and then scaled them to the same scale as the buildings. And they also scanned and did, as Valeria said, they did motion capture on actors, in particular mime actors of one kind or another, wearing costumes and masks and so forth to be able to capture the kinds of movements that people make on a stage. And they used that combined with the 3D model of the mask and the costume that they had to perform drama in the setting of this virtual ancient theatre. It was very effective. It gave all sorts of insights into the way theatre space worked and the way in which people control theatre space. Actors take advantage of the theatre space when they're moving within it. And as Valeria said, it gives you much more of an idea of the scale, of what it must have been like to be in the audience. You can, by manipulating the image in different ways, you can see what it would have been like to be sitting in the front row of one of those massive theatres, not very far from the people on the stage, and what it would have been like sitting up on the back row where you could barely see them, you almost certainly couldn't hear them. And so all this sort of thing. The project was very, very fully documented with lots of written description of all the decisions that were made, of all the evidence that went into those decisions, of all the actions that were taken to create all of this, and all that documentation is published and available. The only criticism that I want us to think about in relation to this project is the issue of sustainability. Where is this project now? How is this project going to survive? Only 7 years after its publication, the unit who created it no longer exists. Some of the members of that unit have a copy of all this data on their own machines, because they didn't want this to be thrown away, but there is no institution currently committed to publishing and hosting this information. So how do we, when we've created a project of this kind, if someone had done this work and they produced basically a book, then we could have copies of that book in libraries, we'd have copies of the digital text in online repositories, and it would be of a scale that could be distributed in true conventional ways. Something of the massive scale and complexity of this kind of project, how do we ensure that the sustainability and the persistence of the research output of these projects? That's again an open question. It's not a criticism of the project team, of course. They couldn't have done anything about the fact that their unit was disbanded, but it is a thing we have to think about when we're looking at this sort of work in the future. And the final project I want to talk about is, again, a slightly unusual project. This was a project using one of these virtual worlds that Valeria mentioned, a virtual world called Second Life, to build what was essentially an educational project, which was an archaeological site and an archaeological excavation in this virtual world. So it was built, I guess, starting in 2007 in the Second Life environment, which was owned by Linden Labs, and the archaeologists, the team, they bought and populated an island called Okapi in this environment, and they built on it a reconstruction of the ancient site of Çatalhöyük. You can see a still of it in this image. We can only see a still of it because I believe that island is now closed, so we can't actually go there and look around anymore. But so this was an interactive environment. You could walk up to that ancient town. You could climb up one of those ladders. You could walk around on the roofs. You could pet a goat walking around on the rooftops there. You could climb down a ladder to the inside of one of the houses and see the architectural context of it. You could walk around to, I think, over on the far side of this building over here somewhere. One of the buildings, when excavated, showed signs of a massive fire. And so you could go into there and you could see a timeline of this building catching fire, and the building would catch fire around you and it would burn down, and you'd see a reconstruction of the events of that activity and that disaster. The entire project was open access, as well as being able to see the results of the reconstruction. All of the tools and the data that went into building this reconstruction were also made public and shared with any researcher who wanted to get hold of them. And a lot of that material is still available, but the project itself is ended. The island in Second Life, which cost a significant amount of money per month to keep going, when the project ran out of funding, that had to stop, and so that island closed down. A lot of the links on the pages are now dead, and it's unclear what the status of the documentation is and how that's going to go forward in the long term. So again, absolutely fabulous project. This is one of my favorite projects ever, but we need to think about how we're going to keep these things alive in the longer term. So those were the three projects I want to talk about. I'll pass back to Valeria to talk a bit about transparency and documentation. You need to unmute, Valeria.
Okay, can you hear me?
Yep.
Okay, perfect. Good. Then I go back to documentation. Well, we spoke about some of the pros of 3D modeling and 3D visualization, and Gabi started introducing some of the let's say issues with 3D that are sustainability and curation and actually even means of publication. It's a new field. It's very young, so there was a lot of let's say pioneers at the beginning and not much standard. And one of the biggest issue that I see in 3D documentation, in 3D visualization, is opacity. And what I mean with opacity is that the kind of images that we usually see when we are presented with 3D visualization of ancient places, especially ancient buildings, are images like this. Which is, a beautiful image. It's very visually striking. The quality of this image is not, of my screenshot, is not incredibly good, but the original, it's actually a very, very good, product from an artistic point of view. The lighting is excellent. The texturing is excellent. It's supposed to be a model of the house of the tragic poet in Pompeii, and it's definitely something that is will catch your attention if you see it. But what if I wanted, for example, I wanted to know why that door is exactly that height and not another one? Why is the color of the paintings that particularly shade of yellow and not completely red? Where is the information that allows me to assess this output and to treat it as any other scholarly output. So where is the information that tells me what are the sources for this image? What are the, if there were material remains still available, if there were traces of that fresco, if it is relying on, I don't know, Vitruvian standards, if it is relying on information coming from nearby houses that actually survived, we don't know. This image, although definitely beautiful and actually believable, it's completely opaque. We have no means, we scholars, we experts, or we general public have no means to assess this image. And maybe there is a huge amount of research behind it. Maybe there are very good experts that have, studied all the possibilities, have made hypotheses, have chosen the most reliable hypothesis, but we just don't know about it. In this sense, this image is completely opaque. And as long as 3D visualization is opaque, it cannot really be used for scholarly purposes, because if it cannot be peer-reviewed, if it cannot be cited, if it cannot be criticized, then it is not a piece of scholarly work. If it cannot be repeated, it doesn't comply to, to the scientific method. So it is kind of understandable why a lot of scholars are actually quite diffident towards 3D visualization, why it is very often regarded as just, something for public engagement, for communication. But actually, I mean, the solution wouldn't be to discard 3D visualization, but to try to make 3D visualization actually transparent. And this issue of transparency is actually not a new thing. We didn't just notice that 3D visualizations are very opaque. It was a concern from the very beginning of the use of 3D visualization in cultural heritage. And that's why a number of experts of 3D visualization for cultural heritage specifically, they met in London and they discussed some sort of guidelines, and they published these guidelines under the name of the London Charter. That is online, you can Google it, you can find it, and it's very simple but interesting reading. I mean, it does set some very sensible guidelines for the use of this technology in cultural heritage. But in particular, I want to bring your attention on one of the principles, that is that every 3D visualization must be documented. And the documentation has to be made available along with the 3D visualization so that anyone can actually assess it and anyone can check the nature of the sources. However, the London Charter was published in 2006, I believe. So everyone agreed that that was, the right thing to do. Nonetheless, there are still very, very few attempts at full documentation of 3D visualizations. And there are many reasons for that. It's not just about laziness. It's that documentation of 3D visualizations, it is actually hard and complicated. In the first place, it is difficult to publish, both from a technological point of view. I mean, now the situation is getting slightly better, but it used to be very, very complicated to mix 3D files with other kind of files, with text and with other images. I mean, it was all very, very clunky. Definitely, you needed some special viewers to see 3D files. I mean, it was incredibly complicated from a technological point of view to put different kind and different media together. But also from a sort of more practical, economical point of view, because it's not easy to find someone that wants to pay for your documentation, because all the attention when talking about 3D visualization of cultural heritage is on the product. So the institution that maybe is paying for the research only wants to pay for the product, the thing, the final image. And it is very hard to convince them that documentation is actually, I mean, it's part of the product, cannot be erased, cannot be hidden. But I mean, it's not easy to convince a funding body to pay for documentation. It is actually as much work as doing the modeling, if sometimes not even more. In fact, I mean, it is incredibly time-consuming and needs a lot of attention and care and focus. Also, there never were, and there still are not, clear guidelines on how to do it. Because the London Charter is very clear about the fact that we all need to do documentation, but they don't say how. They don't even suggest how to do documentation. So basically, every 3D modeler, every researcher that uses 3D modeling have been doing it in the wrong way. And so there is no standard, and the different documentations, for example, cannot be compared and cannot be cross-searched because they all use different terminologies. So this equation is kind of complicated. And of course, I'm not saying that because it is so complicated, we should stop trying or we should not document our 3D visualizations. Quite the opposite. I think that the more we try, the sooner we will get to the right way to do it. And there are, of course, a lot of examples, and they all are interesting, and they all are, in a way, partially successful. So, for example, one of the quite popular way to document at least generally, at least in a broad sense, 3D visualization is to use a visual code. And this is something that this kind of visual strategies to differentiate between existing items and hypothetical items is something that we already see in 18th century, 19th century traditional drawings of ancient buildings. But we find them again in digital works, like this is, for example, an attempt of documentation, again from the of a fresco in the Oplontis villa, among the very likely elements that are in green, and you can see that they are basically really just the prolongment of what is of what can be seen in the surviving fragments. And then we have yellow for the probable elements and red for the very speculative elements, so a sort of street light kind of approach. Also, there are very detailed prose documentation, maybe using blogs or now even mobile apps, or there are dedicated websites that work as platforms, and they gather all information about the sources of a particular 3D visualization. Or we have mixed publications that they were more popular some years ago. They're now disappearing, where maybe you had the book, and with the book you had a CD with the model. So the book was basically the documentation, and you could browse the model on the CD. And all these examples, as I said, they are all interesting. They all give us inputs, but as you can see, they're all very, very different, and we definitely are still waiting for a standard. If that wasn't complicated enough, for its own nature, 3D visualization of ancient things, ancient buildings, have some additional complications that make documentation really, really tricky. For example, authorship. There are various components that make a 3D visualization. We have the actual mesh, I mean, we have the model, but we also have the textures and the lighting, and we have the research. And not always is the same person that carries out the research and then does the model. So we need to attribute authorship, but also we cannot attach all the information to the file, because that wouldn't be very informative. Maybe we need to attach our information, our provenance information, to smaller elements in the entire model, to to that door, to that column, and not just to the entire temple or to the entire house, but how do we divide this space, this virtual space, both from a logical point of view and from a technological point of view? How do we render only parts of it? And then we have to associate these sub-elements that we have somehow created with their sources, or we have to declare that we have no sources for that. How do we do that? It's not really easy. It's not so straightforward. And sources, they are of many different kinds. Maybe we have to say that. Maybe we should have to differentiate these kind of sources. Also, every modeler, when they build their visualization, they simplify data. You make all the columns identical. Of course, they're not identical, but it is a simplification, and it's very well accepted simplification. But I think it should be documented, it should be declared. And many more. You have no idea. I could talk about this for hours, but I'm going to stop here. Documenting 3D visualization is incredibly challenging, but again, it's not reason for stop trying. I want to close this discussion before we actually start working on our small sample 3D model, say something about secondary sources. Because what we do when we when we build a 3D model of an ancient space is usually relying on secondary sources, and which I like, because in a way it puts us in the same tradition of copying the past. That, you know, it's a very ancient tradition. I mean, the Romans copied the Greek, and the Renaissance people copied the Romans, and the Grand Tour people copied the ruins in Pompeii, and so on. And we are continuing, we are the heirs of that tradition, to the point that sometimes we copy the copy. So we use these representations as our sources. So I want to say a few words about the use of secondary sources in producing 3D visualizations of the past. And secondary sources are a 3D modeler best friends, because a lot of information only survived because someone copied it in the past. Like, for example, this drawing of the mosaic in the Temple of Isis that is now completely lost, but the information about it, this is actually a very good scale drawing. Okay, is the only information that we have about it. It's quite precise, and it's incredible that we don't have the artifact anymore, but we can still talk about it. We can still, you know, make a visualization in which this information is preserved, and that is thanks to Piranesi, that made a drawing of it when it was still visible. But what I want you to bear in mind is that we are very often dealing with representations. And representations are, well, they are representations. They are not the thing. And we should always remember that. And I want to show you another example of secondary sources. And these are pictures of the fresco in the House of Orpheus in Pompeii, that actually is named after this beautiful big fresco. But you can see that it's now really, really damaged. In some areas, it's almost completely fading. So I was working on the House of Orpheus on an hypothetical restoration of it. So I did what, you know, everyone would do. I looked for documentation from past documentation of this fresco. And because Pompeii is by far the most copied, studied, represented site in the history of humanity, I would say, of course, I found a drawing of the fresco that was done when the fresco was still visible. And this is a drawing by Niccolini that is dated 1854. So I thought, wow, okay, great, amazing. I have a guideline for my hypothetical restoration. I can use this fresco as a texture for my reconstructed building in 3D. But actually, while I was still looking for information about the Orpheus, I found another drawing of the same fresco. I was like, oh, great. We have such an abundance of information about Pompeii. And this drawing is by Presson and is dated only about 25 years after that. So they're not so far from each other. And after an initial joy of having, two sources instead of one, I realized that if you look at these two copies, one next to each other, to be fair, they don't really look like copies of the same original. And in particular, if you focus on the upper right corner, you can see that actually it looks pretty different, to the point that, look at the animals. We have a lion in the first one and an elephant in the second one. Then we have a lioness and an hippopotamus, and a wild boar, yeah, in both. But you see that, for example, the stream has disappeared and all the greenery have disappeared. So, well, there are a lot of details in these two drawings that are not really, I mean, they are not identical, definitely. And my first hypothesis was, well, okay, the second one was actually drawn when the original fresco had started fading already. But actually, Presson's drawing, the second one, for some details, for some area, is richer and has more things in it than the first one. So this hypothesis was not even accurate. It's just that these were two representations made by two different people, and these two different people had different skills and had different agendas and had different preferences and were relying on different printing techniques. I mean, there are so many variables that can and do affect our representation of the past that we should always, always, always bear that in mind when we use secondary sources as our source of information for our own representations. And because I really like to look at ancient representations, I want to show you quickly another example. This is from the Ashmolean Museum. And this that you can see in the picture is a funerary relief that was found in 1666. So again, it was studied and represented many times. And I'm going to show you very quickly a selection of representations of the same identical artifact through centuries. So we have this one, and then we have this one, and then we have this one, and this one. Now you can see that some of them are really, really, really incredibly different from each other, to the point of being, vaguely amusing. I really like this knight one with the, with the hairstyle of the knight that is completely made up, and these representations usually tell us as much, if not more, about the time in which they were made than they tell us about that they are actually documenting the ancient Roman Empire. But this is again to point out that all representations are biased. The representations that we make are biased, even though we might not see that. And also, another thing that I quickly want to point out is pertinence. I am used to work on images, and I work with objects, so my attention was immediately drawn to the human figure, and I immediately compared how different this chap looks in the 5 different representations. But if I were, for example, an epigrapher, I would have noticed how different the writing looks in all these representations. And that's because we only represent what we are interested in. We can never represent everything. We can never copy everything. There is no such a thing as a one-to-one copy that is, perfect. And that's why I am between, amused and annoyed when I see images like this advertised. This is, by the way, in the virtual museum of Herculaneum, which is an amazing place. But they really try to sell this place with a rhetoric that I really don't like. That is, this image is a perfect reconstruction. There is no such a thing as a perfect reconstruction. And I believe that our aim shouldn't be to try to make a perfect reconstruction, because we would never know how an ancient building looked like. That is just impossible. There is so much speculation. There is so much intellectually dishonest to say that there is a perfect reconstruction. But it's also not interesting. That is not the point. I think that the point is more, okay, what do we know about this building? What is the information that is available? What are the options? How it has been represented in the past, and why? And so, I mean, the exercise with a few images of the Temple of Isis in Pompeii. That is the building I am most familiar with. And there are a number of incorrect, misleading, to the level of, you know, pure fakery representation of the Temple of Isis. And for example, in this one, all the absolutely massive external wall of the place has been erased, just to you know, allow a better view of the temple. But not only that has been erased, it with a laid out landscape with human figures doing some, you know, not well identified activities. Or we have, you know, representations of again the same space. You see now the wall, that massive wall that was erased in the previous image, but an artificial damage has been introduced just to allow a better view of the building that are behind that wall. And again, we have this hypothetical, let's say, life scene that is, believe me, absolutely not possible in the real space of the Temple of Isis. That is actually a tiny, tiny space, and there is no way that so many people and a cow would actually fit in that space. All these representations of the Temple of Isis, they are indeed still very, very precious in the understanding of the Temple of Isis, and they are sources for my own representation of it. Because, again, my goal is not to do, this is how the Temple of Isis look like, but my goal is to say, okay, this is a representation of the state of the art, let's say, knowledge, the present knowledge, or my present knowledge, to be more precise, about the Temple of Isis. And of course, it can be enriched, and of course, it can be commented, and it can be criticized, and this is the kind of use of 3D visualization that I envision. So, not producing an allegedly perfect reconstruction of a non-survived, a disappeared place, but let's say a hub, a starting point for representing knowledge around that place. If you're still with me, yeah, I hope so. We can start building our own. No, we're not starting building our own model, because Gabby has to talk about our software choices first, I believe.
Well, we're actually almost out of time. We technically should have already stopped. We can talk for about another 5 minutes. So should I quickly whip through our software choices in 5 minutes, and then we just tell people to follow the handout for the exercise? Or do we skip the software? They've got the slides. There's 5 slides showing that, and you quickly talk them through the software very briefly. Which you want to do?
I don't know. What do the people think? Well, I might quickly get started with the exercise, just to explain maybe a couple of basic things about SketchUp that might not be in the handout.
Yeah. So the point, while you're getting that set up, the point of showing you 5 different software options, some of those are much more professional, some of those are very expensive, some of those only work on Windows, some of them have different advantages and disadvantages. SketchUp is not by any means the best of these. The advantage of SketchUp is it's pretty easy to learn. There's a free version, which we'll be using, and it works on both PC and Windows, all of which makes it probably the only one that was viable for an exercise of this kind here. But there are other options if you were going to do this differently. Back over to Valeria.
It is back to me. Okay.
Yep.
All right. Yeah. Well. So the thing that I wanted quickly to tell you is that when you open SketchUp for the first time, you will be asked to choose a template. And it is important, if you want to follow the handout, that you choose the template in meters. So I suggest that one that is called simple meters. And another thing that I very, very quickly want to show you, this is the interface of SketchUp. And really, it is there's plenty of tutorials about SketchUp. You find a lot of them in the SketchUp website. I just want you to share very, very quickly. Let's get rid of this lady. A couple of things that are, let's say, pre-knowledge to the use of SketchUp. So first, I strongly suggest that you use, am I screen sharing? Yeah. You use a mouse, and because it is just better to move and pan and rotate with it. So if you have a mouse, a 3-button mouse, with your wheel, you can zoom in and out. And again, pressing the wheel, you can rotate. So the very quick thing that I want you to show is, let's build a random rectangle. So this is a basic shape in Google SketchUp. And if you click on it, you see that now the surface is dotted, which means that is selected. So if you delete, if you hit delete now, that's what happens. You have deleted the surface, but you have not deleted the lines, because surfaces and lines in SketchUp are 2 separate things, and you need to keep that in mind when you do the exercise. So to ensure that you have all the lines as well selected, you need to see that the lines are blue. So now you have everything actually selected. And what happens if you select one line and delete it is that the surface disappears, because of course there cannot be surface if the polygon is open. And okay, these were some, let's say, pre-knowledge that might be useful for your SketchUp exercise. But everything else you will find in the handout, and you can download the texture from the GitHub page of the class. So you should have everything you need. It's a step-by-step kind of exercise. And now I think that time is up. If there are questions.
Yes, thanks, Valeria. I'm sorry we ran out of time there, but that's great. That's really useful. I think that'll be good for the students to work on this. Does anyone have any questions or comments or anything they wanted to ask now? I'm looking at the comments window and at the comments panel on YouTube, and I don't see anything in either of them. I wanted, while very quickly, to apologise to anyone who downloaded the slides from the link in the class outline, because when I combined Valeria's slides with my slides this morning, I put her second presentation first and her first presentation second, which confused me much less what it must have confused anybody else trying to follow along on the slides. It's now been fixed, so if you simply refresh in the Google Slides window, they should all be as they should be. I also fixed a couple of typos in the process. So that should all be good. Tom and Sebastian have both commented that the publication and preservation and data heritage points were very welcome, which I would third that comment, yes.
Yeah, I'm afraid I got carried away with documentation. But
You've been thinking about that a lot, I believe. Cool.
Yeah.
Okay, well, if there are no other comments immediately, feel free to get in touch via the usual channels if anyone has any comments about this in the meantime. And next week's class is the Carto class. Is that right, Tom?
I think so.
Is there any software to download or anything else people should do in preparation for that class? You're still muted if you're speaking, Tom.
I was typing wildly, but you're right. Perhaps speaking is a better choice. I think anybody who wants to actually participate needs to come with some places that they'd like to map. Ideally exported out of Antiquity a la carte or another data set that gives you GeoJSON or a standard data format. But I will be going through those steps kind of briefly at the beginning, so there's it's not like you'll be lost. The other thing is, if you actually want to have your hands on mapping in CartoDB, which is now called carto.com, you'll want to get one of their free account logins in advance. You don't have to fool around with that. But otherwise, a lot of the considerations, though we'll illustrate them with particular software, are going to be more general concerns, both with respect to what it is we try to map, what the visual rhetoric is that we use in mapping, and then actually kind of what some of the basic steps are to making it happen, and that will translate from tool to tool. So if you got something else that you have started using already, just bring that along and be prepared to do lots of mutatis mutandis in your head, and it'll all be great.
Cool. Great, thanks. So basically, yeah, get a carto.com account and bring along some geodata. So some of my students will, they started being able to plot the output from Recogito into Google Maps. So
I think that that output from Recogito or whatever our preferred epical pronunciation of Latin-ish words is now, that output would be a great thing to start with.
Cool. Great. Okay, we look forward to that. And
me too.
Thanks very much. And thank you again, Valeria, for a very, very interesting presentation. And I'll speak to you all next week. Bye.